The Explorer spacecraft from NASA, the farthest spacecraft capable of traveling, continues its incredible journey across the universe. For nearly 50 years, Explorer 1 has been sending significant information back from the universe's farthest reaches, completely improving our comprehension of space. However, the unexpected transmissions coming from this shuttle have provided remarkable indicators that have left the entire space community in awe and perplexity. These indicators have sparked discussions about whether they are the result of a technical error or a clear indication of something unprecedented, perhaps even extraterrestrial life joining us on our journey. Let's investigate the secrets surrounding these exceptional transmissions and explore what might lie beneath the surface of space. Beyond our planet, the mysteries of the universe have been a principal focus of space exploration since its inception. The introduction of missions like Voyager 2 and Explorer 1 marked some of the most ambitious space missions at the time. NASA launched Voyager 2 from Kennedy Space Center on August 21, 1977, beginning a new era in space travel. Just 14 days later, on September 5, Voyager 1 followed, preparing for an unforgettable journey. Each of these twin shuttles weighs approximately 720 kilograms, about the weight of a small car. They were launched during a rare alignment of the outer planets, which significantly contributed to their trajectories and mission success. A historic space odyssey. The two spacecraft traveled in different directions and at different speeds. A pivotal moment occurred on December 15, 1977, when Voyager 1 outpaced its twin due to their distinct routes. Since then, Voyager 1 has become an essential resource, providing significant information that has altered our understanding of the universe and its many phenomena. Before we delve into Voyager 1's most remarkable recent discovery, which has drawn the attention of the entire scientific community, let's revisit some of its major achievements. In 1978, during its Jovian imaging mission, Voyager 1 was positioned approximately 265 million kilometers from Earth. By January 1979, it had begun an extraordinary mission, capturing a 100-hour time-lapse film of Jupiter's rotation. The series of 3,750 images provided exceptional insights into Jupiter's dynamic atmosphere, including its numerous characteristics. The spacecraft also discovered a thin ring around Jupiter and two previously unknown moons, significantly improving our comprehension of the gas giant's intricate system. To ensure the spacecraft's safe entry into Titan's orbit, corrective maneuvers were implemented. Following the success of the Saturn mission, specialists decided to redirect Voyager 1 and 2 beyond the solar system's boundaries. Beyond the solar system. Traveling at an astonishing speed of 325 million miles per year, Voyager 1 officially began its interstellar mission in January 1990. During this period, it made significant discoveries, including the identification of 4 additional moons. The largest, Enceladus, was among them. On February 14, 1990, Voyager 1, located approximately 6 billion kilometers from the Sun, captured the famous family portrait of the solar system. This collection of 60 images included some of the most breathtaking perspectives ever taken. Meanwhile, Voyager 2 achieved remarkable feats as well. It recorded wind speeds exceeding 13,100 meters per second on Neptune, the fastest ever observed in our solar system. It provided critical insights into Neptune's atmosphere and its largest moon, Triton, where surface temperatures dropped to a frigid -391 degrees Fahrenheit, making it one of the coldest locations in the solar system. Triton exhibited ice volcanoes that released gaseous nitrogen, propelling frozen particles 5 kilometers into the sky, an unprecedented phenomenon. These discoveries expanded our knowledge of the outer planets, proving that Jupiter's and Saturn's moons, once thought to be inactive, are in fact geologically active. The future of Voyager. Voyager 2 achieved several historic milestones, including being the first spacecraft to fly by Uranus and the only spacecraft to visit Neptune. NASA employed various strategies to extend the operational lifespan of these spacecraft, including shutting down non-essential systems to conserve energy. The mission is expected to conclude in 2030, marking a bittersweet moment for the scientists and engineers who dedicated their lives to this extraordinary endeavor. Both Voyager 1 and Voyager 2 are marvels of engineering. Designed as stable rotating platforms, they move at a rate more than 100 times slower than the hour hand of a clock, an intentional design choice to reduce visual blurring as they traverse space. Before reaching the outermost planets, the spacecraft transmitted Jupiter-revealing images, showcasing its swirling clouds and iconic features, such as the Great Red Spot, a massive storm that has captivated scientists. However, the most significant discovery came from Io, one of Jupiter's moons. Voyager's instruments detected strange signals from Io, later confirmed by images of volcanic plumes erupting 100 times more powerfully than Mount St. Helens, covering an area nearly the size of France. As the spacecraft continued their journey, their cameras were eventually turned off to conserve power. Before entering interstellar space, NASA decided not to capture images of Mercury or Mars due to mission constraints. A legacy that continues. Beyond the Voyager probes, NASA launched other important spacecraft, such as Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11 as the farthest spacecraft from Earth. Despite the absence of other probes in deep space, Voyager 1 continued its solo journey for 14 more years before officially crossing into interstellar space on August 25, 2012. The success of the Voyager missions was made possible through a variety of innovative strategies, particularly gravity-assisted maneuvers. These maneuvers allowed the spacecraft to slingshot around planets, gaining velocity without using additional fuel. Imagine two fearless spacecraft navigating the planetary system, using the force of gravity to propel themselves forward. This celestial dance reduced fuel consumption and enabled them to achieve the necessary speeds to reach their destinations. The final journey. As the Voyager spacecraft approached the final phase of their missions, they continued to provide valuable data about the interstellar medium. Scientists eagerly await the final transmissions from these legendary explorers, knowing that their discoveries have forever changed our understanding of the universe. Even after their power fades, the Voyager probes will continue drifting through space, silent messengers of humanity's insatiable curiosity. The enduring legacy of the Voyager missions. As Voyager 1 and Voyager 2 drift deeper into interstellar space, their instruments continue to send back valuable data. Despite operating on dwindling power reserves, these spacecraft have exceeded all expectations, rewriting our understanding of space and time. The challenges of deep space communication. One of the biggest challenges in maintaining contact with the Voyager probes is their increasing distance from Earth. Signals from Voyager 1 now take over 22 hours to reach mission control at NASA's Deep Space Network, DSN. As the probes move farther away, their transmissions weaken, requiring sophisticated radio telescopes to decipher the faint signals. NASA has already shut down non-essential systems, including cameras and certain scientific instruments, to conserve power. However, engineers predict that by 2030, the spacecraft will no longer have enough energy to continue transmitting data. Yet, even after their final signal is sent, Voyager 1 and 2 will remain as silent travelers, carrying humanity's golden record, a time capsule of Earth's culture, sounds, and messages, meant for any potential extraterrestrial civilization that might one day discover them. What lies beyond? Both spacecraft are now sailing through the interstellar medium, a region beyond our solar system filled with charged particles, cosmic radiation, and magnetic fields. Scientists are particularly interested in how the Sun's influence diminishes in this vast, unexplored space. As Voyager 1 and Voyager 2 continue their final mission, they are expected to encounter the Oort cloud, a vast shell of icy objects surrounding the solar system, extending nearly 2,000 times the distance from the Sun to Pluto. It could take Voyager 30,000 years to pass through it. Uncharted interstellar space. Beyond the Oort cloud, the spacecraft will travel through a void where stars are separated by light years. They will likely drift for millions of years before encountering another star system. The final transmission. NASA scientists are preparing for the inevitable moment when the Voyager's last transmission arrives. It will mark the end of a historic era in space exploration, but their impact will live on. The data they have provided continues to shape future missions, including upcoming interstellar probes that may one day follow in their path. Even as their power fades, the Voyager spacecraft will continue their silent journey, forever drifting among the stars, our first human-made messengers to the vast unknown. Jupiter was approached by Voyager 1. The planet's significant gravitational attraction accelerated the spacecraft, increasing its speed. Any deviation from precision was unacceptable. A slight miscalculation in the angle or speed could have produced a disastrous outcome, despite the overwhelming precision required. The creative thoughts behind these missions were carried out successfully. They utilized gravity multiple times, launching the spacecraft on an incredible journey. Thanks to these cosmic maneuvers, Voyager 2 used gravity assists to reach Jupiter, Saturn, Uranus, and Neptune. The success of the Voyager missions owes a lot to these gravitational assists, which highlight the remarkable journey of these exploration spacecraft and the abundance of information they have provided. We eagerly await further updates on the examination of Voyager 1's most recent findings. Both Voyager 1 and Voyager 2 have experienced anomalies but continue their missions beyond the natural limits of our solar system. Their discoveries include Saturn and the moons of Jupiter, as well as the moons of Uranus and Neptune. Time-lapse images reveal Jupiter completing 10 revolutions in striking detail. These discoveries also include the detection of a small ring and additional moons, significantly improving our understanding of Jupiter's comprehensive system. Voyager 1 discovered 4 more moons of Saturn, Rhea, Mimas, Enceladus, and Tessis, and captured unexpected images of Saturn and its rings, offering fresh perspectives on the planet's intricate system. Through its visits to Uranus and Neptune, Voyager 2 provided valuable data about their moons and atmospheres, further enhancing our understanding of the outer regions of our solar system. After completing their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, gathering information about the vast environment beyond our solar system. Our exploration continues to expand, and we anticipate further insights from the latest Voyager signals and their implications for our understanding of the cosmos. The extraordinary journey of these spacecraft remains a source of inspiration for scientists and space enthusiasts alike. Their groundbreaking accomplishments continue to push the limits of human knowledge and exploration, highlighting the limitless potential of space. The Voyager missions have provided a treasure trove of information about our solar system and beyond. In addition to their iconic images and scientific data, the spacecraft carry the Golden Record, a unique artifact designed to share the story of Earth with extraterrestrial life. This record contains selected sounds and images representing the diversity of culture and life on Earth, including 55 greetings in various languages, music from different cultures, and natural sounds such as thunder and whale songs. This message in a bottle symbolizes the hope that, if intelligent life exists elsewhere, it may one day find and understand this glimpse into the essence of humanity. Both Voyager 1 and Voyager 2 were equipped with scientific instruments that have revolutionized our understanding of space. These instruments include magnetometers, cosmic ray detectors, plasma wave instruments, and imaging systems, each providing crucial insights into space phenomena. For instance, magnetometers have revealed the complex magnetic fields of Jupiter, Saturn, Uranus, and Neptune, shedding light on the relationships between these planets and their environments. Plasma wave detectors have helped us understand how the solar wind interacts with planetary atmospheres and magnetospheres. One of the most remarkable aspects of the Voyager missions is their ability to measure the boundary of the heliosphere, a vast bubble of particles and magnetic fields created by the Sun that surrounds the solar system. As Voyager 1 approached the edge of this boundary, it detected a sudden shift from the solar wind to the interstellar medium. This data has been crucial in shaping our understanding of the heliosphere's structure and its role in shielding Earth from cosmic radiation. The spacecraft's observations have confirmed the existence of a distinct boundary where the solar wind slows down and becomes denser, known as the termination shock. Beyond this lies the heliosheath, a region where the solar wind interacts with interstellar space, creating a dynamic and complex environment. Voyager 2's journey has been equally significant. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide valuable data on the outer reaches of the solar system. Voyager 2's observations of Uranus were particularly striking, revealing a uniquely tilted magnetic field that deviates significantly from the planet's rotational axis. This discovery challenged existing models of planetary magnetism and spurred further research into the magnetic fields of other celestial bodies. Beyond their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The stunning images of distant planets and their moons, combined with the extraordinary stories of the spacecraft's journeys, have captured the imagination of people worldwide. Pictures of Saturn's rings and time-lapse views of Jupiter's moons, especially Io's volcanic activity, have inspired countless individuals and have been featured in educational materials, documentaries, and popular media. As the Voyager spacecraft continue their journey beyond the solar system, they serve as humanity's silent sentinels in the vast expanse of interstellar space. Their instruments, though aging, still relay valuable data about cosmic rays, interstellar plasma, and the structure of the heliosphere. These findings help scientists refine models of the Sun's influence on its surrounding environment and provide insight into the transition between the solar system and interstellar space. One of the most significant moments in Voyager 1's journey came in 2012 when it officially crossed the heliopause, the boundary where the Sun's influence wanes and the interstellar medium begins. Scientists detected a dramatic shift in particle density, confirming that the spacecraft had entered a region where the solar wind no longer dominated. Voyager 2 followed suit in 2018, providing additional data that helped confirm the nature of this boundary. These observations have revolutionized our understanding of the heliosphere's protective role and how it interacts with interstellar space. Despite their incredible longevity, the Voyagers face an inevitable decline in power. Each spacecraft is powered by a radioisotope thermoelectric generator, RTG, which slowly loses efficiency over time. NASA engineers have been carefully managing power consumption, shutting down non-essential systems to extend the life of the remaining scientific instruments. It is estimated that by the mid-2030s, both spacecraft will lose the ability to send data back to Earth, drifting silently through the cosmos as relics of human ingenuity. Even after their transmissions cease, the Voyager spacecraft will continue traveling through the galaxy, potentially for millions of years. Carrying the golden record, they serve as a time capsule of Earth's culture, history, and diversity. If another intelligent civilization were to find these spacecraft, they would encounter a carefully curated selection of sounds, images, and greetings that represent humanity's place in the universe. The impact of the Voyager missions extends beyond scientific discovery. They symbolize the unyielding human spirit, the desire to explore the unknown and reach beyond the boundaries of what is possible. The images they captured, from the swirling storms of Jupiter to the icy rings of Saturn, continue to inspire generations of scientists, engineers, and dreamers. Among the most famous images taken by Voyager 1 is the pale blue dot, captured at the request of astronomer Carl Sagan. This image, taken from over 3.7 billion miles away, shows Earth as a tiny speck suspended in a sunbeam, a humbling reminder of our place in the universe. Sagan's poetic reflection on this image underscores the fragility of our world and the importance of cherishing and protecting it. As we look ahead, the legacy of the Voyager missions lives on in modern space exploration. Missions such as the Parker Solar Probe, the James Webb Space Telescope, and future interstellar probes build upon the foundation laid by Voyager. The lessons learned from these pioneering spacecraft continue to shape our understanding of the cosmos and fuel our ambition to explore even farther. For now, the Voyagers press on, their faint signal still reaching Earth across the vast distances of space. Each transmission, though weak, carries with it a testament to human curiosity, perseverance, and the desire to seek knowledge beyond the confines of our home planet. As long as they continue their silent voyage, they remain a beacon of exploration, a testament to our reach into the unknown, and a reminder that our quest for discovery knows no bounds.